Thank you everybody for joining. If you want to type in a little bit, there's a chat box, this way I can see, who's there, who isn't. Hopefully we have a lot of repeat people over here. So welcome. Welcome to another training seminar series. This is the Lunch and Learn. And of course, today we're going to discuss ABS for commercial motor vehicles. And if you notice, it's going to be part one. Now, by the way, you have handouts that go along with it. Okay. So back to this, ABS for commercial motor vehicles, part one. It's one of those subjects that I decided to break it up into two parts. Part one is going to be more or less an overview. I'll put this on over here. We'll click it. That's me. We're not going to worry about me. We're not going to worry about that, but we'll get into the first slide here. But part one is going to be more or less of an overview. We'll get into a little bit of regulatory portion of it. And the reason I want to do the overview and what is ABS all about is because it is so important I'm one of those believers. I just did a critical thinking in Pittsburgh, and one of the things in the critical thinking slide, this was for the automotive, is trying to get a game plan. And the first thing that we discuss in critical thinking is get on site someplace, go anywhere into your information systems or whatever you're using. The first thing you should always try to do is, what is happening here? How does it work? And that's what I want to accomplish, because I'm a firm believer, if you know how it works, you're going to basically figure the whole system out. You really won't need me, you just need some extra information. And that's what I'm doing. The other reason I picked ABS as a subject is that I do a lot of driver trainings. So on and off, when I get a fleet and I do driver training, it takes me about 4 hours to do it. We covered some of the violations and stuff. And when I get into that portion of the violations with ABS, I get this really it's not antagonistic, but boy, the drivers are over there, like every one of them, they don't get it. They write up the vehicle with the ABS issue, the light is on, they pick it up next day, the light is back on, and they're over there like this is ongoing, and I hate to say it, but one of the things they're over there is like, why can't they fix it right the first time, And it is important. We need to take the drivers in consideration, because us technicians, mechanics, we do not get pulled over on the roadside, they do. And if that ABS isn't functioning the way it should, it is a violation on the roadside. And this is why the drivers once in a while get picky. So let's see what kind of trouble we can get into. So let's make sure, yes, everybody, I hear you, Temple, Texas. Yes, great guys, that's absolutely great. Last month when I did part one of the disc brakes, boy, I tell you, we had an issue for the first 10 minutes, and I wound up, it straightened out, but I wound up re-recording it the following day, and Dorman shot it out. So thank you guys, appreciate that. Let's start out with a little bit of history. ABS is used on trucks, trailers, cars, believe it or not, on motorcycles, and of course has been in aircrafts. The concepts do have a long history. We can go back to 1908. It was first introduced. They call it slip prevention regulator for rail vehicles. And there's a guy in France back in 1920. He experimented with the hydraulic brake system on his aircraft brakes to reduce the risk of tire slippage. And engineering-wise, that's why you always hear slip, wheel slip, slip, slip. First I was a little confused whenever I belong to Society of Automotive Engineers, and I'd hear the word slip. Basically, I'm more comfortable. Hey, my wheel is ready to lock up. My brakes are coming on. But nevertheless, back in 1930, a system called Desolested used direct current generators. Hey, direct current generators to measure wheel slippage used in railroads. Just think about how we're looking at AC now, from your sensor. 1950s, Dunlop Maxred anti-skip system was used in aviation. First fully electronic analog system was developed in 60s for the Concorde aircraft. And of course, we definitely we migrated it into the cars. ABS 71 at Fiat Now it's a standard. Pretty near every car has ABS, okay? Originally they called it anti-skid till the patent was sold to Bosch, and Bosch, of course, renamed it what you guys know now as ABS. So now let's jump into the commercial vehicle. WAPCO, Westinghouse, they began developing anti-lock braking system, commercial vehicles. I went online and I wanted to see who the players were. WAPCO definitely, most certainly, is a huge player. It started out as a huge player. First ABS, electronic controlled air suspension, automated manual transmission, and you see it on the list. But when it comes to ABS, this 2007 collision mitigation system with active braking, the ABS is the foundation for any of those stuff there. So, and of course in Europe, very big, EBS. Okay? EBS, look for it to come into our country, as a mandate. Now, ABS history as far as my time, when I first started, required in 1975 under the Federal Motor Vehicle Safety Standard. It was kind of an indirect requirement. That was a pivotal year where, with the Federal Motor Vehicle Safety Standards in the 121 pertaining to air brakes, they came up with all sorts of tests that the manufacturers have to do, pressures, thresholds, stopping distances, and so on. So the easiest way to do it was, it's like, hey, maybe if we put some of this stuff, this ABS, it might help some of those areas. And that's why you want to look as an indirect requirement. However, in the day, it had many problems. And I'll be honest with you, I'm not going to make too many war stories, but when I first started, and I first started to see this ABS on vehicles, we didn't know what ABS was about. We popped the wheels off. We were there, what the hell are these notch things over here? What is this thing sticking in there? It's got a nut holding a jam nut, couple wires coming out and stuff. And we didn't have the means of educating, or we didn't have Google. We didn't have none of that stuff in the day. So I'll give you some examples, and I'm not kidding. When these ABS things came on, I would hear drivers say, and I'll give you an example, like, oh, you should have seen, when I was going down the road, I happened to look over, and just when I slammed on the brakes, I saw this electrical motor-driven garage door come down. And the guys, before you know it, they'd be talking with each other. Before you know it, you got another guy. He's over there like, oh, you're right. You should see, when I had to slam on the brake, I happened to look over to the side, and somebody's garage door was opening up. Before you know it, stuff like that will be going on. And I actually, honest to God, I actually heard some guy say, someday, these signals that are coming from the ABS, they're going to hit an airplane just when it goes into ABS mode, and it's going to screw the airplane, and the airplane is going to come crashing down. But regardless, we didn't know, as each year went by, and especially now with the new generation, the education has really been outward. The manufacturers out there, and the manufacturer has been very straightforward and forward with giving us information on this stuff. So again, the courts back in 78 overruled it. It did disappear in USA. Now, and that happens quite often. In Europe, they did not get rid of it. They stayed with it. They took that and turned it into a second generation, into all digital control. They worked all the bugs out it. And of course, we looked at, National Highway Traffic Safety Administration, they did a study. They revisited this thing, and that's back in 1988. They looked at 200 tractors, 50 trailers, and they says, you know what? This second generation is really working well, and even though there were manufacturers out there that offered it as an option, but these dates right here, guys and gals, March 1st, 1997, all tractors, March 1st, 1998, ABS mandatory, March 31st, 1999, and you can see it, you have it in your handout. It became mandatory. It was cast in stone. It was part of the Federal Motor Vehicle Safety Standards, and of course the Federal Motor Carrier Safety Regulations picked it up, and that's where they pick it up for the roadside violations. So I was going to say, I remember when these things first came out. So then March 1st, that date was always huge. So I'm just going to pick up this truck and trailer. So a vehicle would get pulled over on the roadside, and a lot of times everybody will forget this March 1st here, and they'll see a registration 1998. And I would tell everybody, you can't either write it up or be careful that just because it says 1998, that doesn't mean it's March 1st, because you can build a truck just like cars in November of 1997 and you put it on the registrations in 1998. So that was an issue in the earlier days. You know, they would get written up, they would come in, and guys in the shop would look for the ABS, and they'd give me a call and say, man, somebody I think took them up. Nope, look at the door tag. What's it say? And chances is pretty good it never had ABS, just because it was built before March 1st. So just wanted to throw that in. As far as the system goes, okay, the system is stupidly simple. There's nothing complicated. You're really looking at just a basic system over here, you know, and you can actually picture it being a car if you want. You know, same thing. You got your computer, you got your ECU, you're going to have a sensor, you got a tooth wheel, and we'll take each one of these components a little bit more. But still, you have an ABS brake control valve, your modulator valves, but you still got your base air system. You got your foot valve over here, you got the chamber. So this is an add-on, basically, is what we did. Now, the other thing that happens with these systems is the configurations, okay? Throughout the life of these ABS systems that we've had it, we love the wheel-by-wheel control. You get sensing, each wheel sensed, modulator for each valve. There's your brake chamber. Computer makes your decision here. You still got your relay valve that you would always have with your regular brake system, okay? But whatever happens at this wheel, each wheel gets controlled by itself. So we call it wheel-by-wheel control. There are systems, and there have been, like, and I'm not quite sure the benefits of this, and I don't really want to get into it, but this is a side control. This 2-sensor 2 modulator also could have a 4-sensor 2 modulator, uses 1 ECU dual modulator valve assembly and 2 or 4 wheel speed sensors. The ABS sensors are mounted on 1 or 2 axles only. The curb and roadside of the trailer are controlled separately. So it's like, yeah, you're controlling these over here, but you're only sensing from one. But the bottom line is that just realize we have had different kinds of systems out there. Now, Meritor Wapco, they have been very, just so you see, you're going to see a few slides with Meritor Wapco. Tim Hale, from Meritor, and a lot of these Meritor people throughout the years, they've been very gracious with me. I've actually built a brake board that we'll use next month. You know, they provided me the computer and sensors and everything because they feel it's very important that everybody has access to information. So they gave me always okay to use some of their slides to pinpoint and show, you know, I mean, it's their systems, and that's why you see the Arvin Meritor Wapco. Your most basic system, again, is this 2-sensor, 1 modulator basic. It's a single relay valve. It's got a couple electrical connections, you know, solenoid is external, diagnostic, and we'll get into it a little bit more, you know, and 1 generic input-output is available. And of course, you got your control ports, okay. There's serviceability, elimination of LED on top of the ECU, bracket mount, or tank mount. Okay, and this is basically, you know, what you're going to see, for example, on a trailer. It's about as basic as you can see. The earlier versions were very boxy, and if you go to try to get a replacement for that earlier valve, you're not going to get it. But this is a drop-in. And what I've always liked about all of these systems is it's kind of more or less a plug and play when it comes to harnessing. The only difference is you got an older trailer and you pull that relay valve off. A lot of you guys, if you've done that, you've noticed your height by the cross member, you might have to do a little kind of configuration to make it fit over there, you know. So, you know, my monitoring chat box, you know, and this is another very popular one you see over here. 2-sensor 2 modulator standard valve, has only 2 sensor outlets, cannot be upgraded. Okay, And I'll hold one of those up later on when we get into the computer and stuff. So, you know, 4 sensor 4 modulator valve. And the reason I have this is, if you look at the schematic here, this graphic, guys, look, you still have your chambers inside the wheel. Somebody put some toner rings in there, you know, and I only see 2 toners over here, so that's telling me I'm only sensing this one drive axle over here. And of course, you know, it's nice to know, for example, this is a relay package over here, okay? This is a frame mounted ECU, and I've got your separate solenoids over here. A little bit on this frame mounted. When these frame mounted came in with a little black cover, you unbolt the bolts and everything, I was totally amazed in the environment that they get. I really haven't had any issues with the connections. The connections are pretty good. If you open up the cover, and again, I'm not sure, you know, you guys are probably from everywhere. I see somebody from Alaska, you know, Las Vegas and stuff, but over here, Alaska, I guess, is pretty close. What we have over here with the snow and stuff, the connections look pretty good. I very rarely see any connection problems. Do they fail? Yep, it's like anything else, they'll fail, you know. Now, this is just a nice schematic again. You know, when I do my brake courses, regular brake courses, everybody gets a little schematic so they can follow what we're doing here. Of course, you notice your foot valve over here. You have a quick release valve over here, and this happens to have the solenoids for the ABS separate on each side of the chassis. But you can get it as a package, okay? This quick release valve is combined as a package over here, just like you see over here, okay? So I'll show you the add-on to this. I'm gonna click it once. By putting this little guy over here, you turn this into a traction control type of a system. Okay? So I'll hold this up for a second, you know. If you can zoom in over here, Bobby. This is what it would basically look like, you know, just in case, give you a better view. If this is your first exposure to it, typically you would have a relay valve. This is the one in the center here, okay? Prior to ABS, that was always there. But this stayed with it, right? And then on each side, because it's a reel, this is where you have your electrical solenoid valves. And of course, over here, you got the plug. It's a 3-plug system over here. But what happened is, if it's just a base ABS, you won't have this on. You will have this solenoid added for traction control, and to be very honest with you, a similar solenoid works with a active braking. So, you know, and we're taking steps here. We're taking steps. We'll look in what kind of trouble we get into. So I actually put that on my slide. An active brake valve is installed on the base ABS system. When it is part of the rear valve package, the active braking valve is attached to a relay valve. On individual modulator valves, active braking valve is mounted on there. Vehicle with ATC installed will have an indicator lamp on the dash. So basically what that active brake is involved into a, you probably call it collision mitigation, that it is an electrical solenoid. So what happens basically is, you know, typically without this valve over here, you have input, you know, every time you step on the brake, this is your control over here. Pretend this isn't here. You step on the foot brake, air goes in here, and if you're not in ABS mode, these solenoids are de-energized. So when you step on the brake, you're still shooting air out to the chambers over here, okay? They'll go out to the chamber, one on each side. But what happens is, if via the ECU, you get in a situation, it's like, oh my, we're heading, and it gets very involved. You know, we're getting really into electronics and multiplexing. But all of a sudden, it goes beep, 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 beep. You're getting awful damn close to the vehicle. And after a certain point, the computer says, nope, start applying the brakes in here. And right now, that's a little contentious with here. But the same thing happens with traction control. You know, computer says, hey, I want to put the brakes on because you're slipping. And then if it's for traction control, you can see electrically it actually, you know, activates, you know, that portion of it. So traction control is really a mirror image of ABS. 6 sensor with ATC. You can't get any better than that. Sensor on each wheel and so on, you know. Then the question comes in is like, especially when these first came out, it's like, if you were the person buying these vehicles, if you had to buy a fleet, why would I want this? Why would I even, I don't get it, you know. So what happens is the feds came up with a nice little, and I took some of these slides from there, and it basically shows you, okay, that you don't necessarily have ABS on each wheel, but that the steering is so huge, okay? So if you look at this one, the middle one over here, without steer axle ABS, now what you're looking at is you're going down the road, and all of a sudden, oh my gosh, there's an object up front. And you want to steer away from there, and you're going to slam on that brake. I mean, give it everything you want. And chances are pretty good you're going to go into what we call steering plow. Okay? Your steering wheel is turned, your wheels are turned, but you're going straight into the object. So where ABS is a benefit is if you look over here, it allows you to steer away from that object. Right? And that's the whole idea of that slide there. The other issue we have is, you know, and when I get into my regular brake courses, I do a lot with the balance of the braking systems. You know, each wheel has to do its share of work and everything. But realistically, in the real world, you might have a tractor that has ABS, and you're hooking up to an older trailer, no ABS, and these are the different scenarios. So still, okay, depending on who has ABS, who doesn't have ABS, you could set yourself up into some issues still, you know, the jackknives, the trailer swings, and so on. And this is why it's so important to know that, you know, yes, you have ABS, but you always want to drive, pretend you don't have ABS. ABS doesn't give you the right to do stupid stuff on the road, if that makes sense, okay? That system there that used, it needs power. It needs power. I mean, it is a computer. You have solenoids in there. They got a tether. They got to open, close. They got to exhaust and all that stuff. And that takes power. You, at a minimum, you're going to have ground, and you're going to have power. So when it comes to the trailers, you know, that was an initial issue. How do we get power to a trailer? Because you're not going to run around just because now we have ABS. We're going to put a little tray underneath the trailer and put some 12-volt batteries in there. It's not about to happen, you know. So and this is, this is why you see, think about the stoplight circuit in your semi-way connector. Every time you step on the brake, you're putting power there, right? So that was initially a good way of doing it. We've always had that 7th pin, that blue wire in there. That is definitely a place to get your power. And then if you came from the day I did, you might have seen tractors that had the 2 cables in there. Okay, you had with your 7-way plug, and they might have had a dedicated ABS cable. Okay, all 3 approaches have been used, and they're still being used. Okay? Now, the other big issue is we're talking about electrical stuff, you know, and this comes into play with voltage drops. Okay, because if you look over here, it's one thing you got a single tractor and trailer, but let's put another dolly, let's put another trailer. Every time you hook up a trailer, you're going to have another connection. You can have another connection. By the way, just don't look at it as I'm adding multiple trailers, but what about the connections even in a single unit? If you know, you guys know that work on this stuff, you know, when I'm going to get into this voltage drop. But the bottom line is, okay, let's take our 7-way plug over here. For these solenoids to function and tether, okay, you don't want to let it drop below 9, okay, depending on how many sensors, modulators, valves are, 8, and so on and so on, okay. So what basically happens is if you start dropping it too far, you're not going to have enough voltages for these things to work properly. So that has always been an issue. So they decided for this worst case electrical load, okay? And for us guys that work on it, we need to keep that in mind too, by the way, because if we have connection problems, you know, corrosion and so on, we're recreating this whole scenario over here too. This is, if you can zoom in a little bit, Bobby, you can look at this red line here. So this is an example of some issues in the real world. This particular trailer came into our shop, you know, ABS light on the trailer has been on for several years. Trailer was brought from a dealer, it did pass inspection. I don't know how it did that, you know, for a few years. It came to our shop for inspection PM. We noticed that the sensor wires were cut. Okay, so that means somebody was in there, basically, you know, maybe the light was annoying, it was on, so let's cut some stuff, and maybe if we eliminate this, nobody will pay attention. When I get pulled over, you know, the light is off, everybody might think there's nothing wrong. But the ABS light comes on and stays on when powered up. So what basically happened, okay, we could not get it to blink codes, so we're trying to figure out what the hell is going on over here, you know. So we had to go backwards, and what we discovered was someone at one time has been screwing around with it, noticed a white-green wire, and they're pretty near universal on these systems. Okay, that wire belongs to the light. Someone had at one time hooked the blue wire to ABS light. And again, if all you know is, hey, that blue wire is a constant wire, maybe somebody figured, if I could get the light on, I guess I got to hook it up to the light, you know. It doesn't go to the light first, and, you know, the blue wire goes to computer. The computer decides what to do with the light, you know. So I'm trying to keep it simple. Now, I mentioned we're also going to get a little bit into requirements. Now, these are actual requirements. The ABS on tractors, full trailers must control the brake pressure to at least one front axle and one rear axle. There's no ifs and buts about it. So if you're one of those that I'm going to get into it, I have an issue with the ABS, I can't figure it out, you know what, I'm going to disconnect it on the axle, the other axle in the rear has it. You can't do that. These are requirements. The ABS on semi-trailers and dollies must control at least one axle of the vehicle. In addition, the ABS on tractors must control one of the axles with two modulator valves so that the brake pressure on one end of the axle is independent of the brake pressure on the other end. No ifs and buts. These are the regulations. These are the requirements. Now, this is a little bit of huge here. March 1st, 1997, newly built tractors must provide constant electrical power to the tractor-trailer electric connector. From that year on, you gotta have the constant power. Now, and I'll show you in a few slides there, that doesn't mean that you still can utilize the power from your stoplight. Your stoplight winds up being the backup for these systems. So as of that date, vehicles are required to be built with ABS. The vehicle's ABS malfunction lamp must be in clear view of a driver. It must light up when the ABS malfunctions. The ignition key is switched on for short bulb check. And when commercial motor vehicle enforcement guys started to do this, they actually wound up with a real nice sheet of, and it's kind of a flow chart, and basically says, was the vehicle built before this? Is it a truck? Is it a trailer? Was it built after that? And then you follow the flow sheet, because don't forget, you know, you're talking about tractors, you're talking about trailers, and so on and so on. And of course, commercial motor vehicle hydraulic brakes too, you know, they're mandated, you know. Ignition is switched on for a short bulb check, just like you would in your car. You know, you turn on your light, you know, what do you want to do? You want to look at your MIL, right? You look at that little, you know, icon there, you know, to make sure that, you know, at least it comes on. If you do inspections, that's a mandatory, you know. Hey, the machine, we do a NIVAP in New York State machine, and it asks questions before we plug it into the OBD. Did the light come on? Okay, and then the machine tells you start it up, that the light go off, you know. So we're virtually doing about the same thing with ABS, you know. And here's your ABS light over there, you know. 1998, the malfunction lamp on trailer, this is on trailers, must be yellow, mounted on the left side of the trailer. Near the rear, red marker lamp on dollies must be located on the left side. So these are requirements again. And it does the same thing, even if it's a trailer. Okay? Light up when ABS malfunctions, of course. Short bulb check, just like it would in a truck or tractor. Stop and ABS starts receiving electricity. No longer required, this is an old slide, required after February 2009. Now I'm going to tell you, I'm happy that this requirement wasn't, you know, the trailer manufacturer says, oh great, we don't have to put a light on. I am so glad that that requirement doesn't necessarily change, that those lights are on, because what happened was, for me it works out good, and it should work out good for you too, is that the newer tractors, they have that little icon of the trailer on there for the ABS. Well, what happens, and I'll get in a few slides with the PLC, how it works and everything, but what happens is, the premise is that now the driver can sit in a seat and he can see if you have an ABS issue with the tractor. Of course, that light's going to come on. And if you have an issue with the trailer, you have the other icon with the trailer, picture of a little trailer, that will come on and stay on. So that means while in transit, the driver doesn't have to look in the back, you know, and look for the light, is it on, and everything else. But you're looking at communication here. So that opens up the door. Well, hey, that light is on over here. Is it a communication problem? Did something go wrong with my communication? Is that why it's on? Is there a genuine problem? And I try to, most of the time, if I see the corner light still on over there, that kind of tells me I do definitely have a genuine problem on that trailer. So I like it that we kept that light on over there. Now, data from the FMCA motor carrier management information, okay, and this is filtered from the year 2019 to 2023. And your ABS stuff winds up being in 393.55, okay. So in that Federal Motor Carrier Regulation, it says no defective ABS malfunction indicator lamp for trailer manufactured 03/01/1998. Those 2000 to 2023, okay, 225,639 violation. Guys, I can't emphasize, that ABS is such an easy hit over there for vehicles when they get pulled over. I mean, all you got to do is look at the bulb. You don't have to crawl underneath her. It's not like you're trying to look at brake linings, hoses, and everything else. It's like you just do a simple walk around or peek your head in through the window, and there it is. So this is why, you know, it's important we really get comfortable with ABS and we make sure that we fix them properly. And of course, some trailer manufacturers, you know, Merter Wapco, for example, if you notice here, it says if the ABS indicator lamp comes on and stays on when you apply the brakes to a moving vehicle, the trailer ABS is not working. ABS must be serviced as soon as possible, okay? So in this scenario, I'll tell you right now, when you stepped on the brake, okay, your ABS actually did kind of come on, but you weren't using constant power, and that light lets you know, it's like, whoop, you do have a problem. This particular one here, you know, and every once in a while you run across something stupid. This was configured, if you notice over here, I got two fixed axles over here, and they're airbag suspension, but also I have a lift axle up over here. So the lift axle is kind of like an option once in a while. You remember the regulations, the options? We didn't necessarily have to have it to meet the requirements, but this particular company wanted ABS all around, so you have a second one. By the way, this also has a system in there that uses the wheel speed sensor, that if somebody backs up this trailer, it'll automatically lift that axle up. So it's as simple or as complicated you want to make it. Okay? When replacing bulb using, and this is, you know, most of the time I don't have problems with the LEDs because they have that integral load resistor built into them, you know, but the early ones weren't set up that way. So, you know, rule of thumb, you know, incandescent works just great on there, yeah. Indicator lamp operation on trailers. Trailer manufactured. Again, I'm rushing too fast. Indicator lamp operation dependent on whether the ABS is powered by the stoplight or constant power. And all you got to remember, guys, is that a trailer manufactured prior to February 28, 1998, or manufactured outside the United States, whatever you bought that trailer in Canada or whatever, the ABS may be either stoplight or constant power. If it's manufactured March 1st, 1998 or later and was manufactured in the United States, it will have constant power capability, excuse me. And again, it's mandated through the Federal Motor Vehicle Safety Standard 121. Now, most ECUs manufactured prior to September 1997 require all sense wheels to detect for. Look, what happens is that the early ones, if you did your fix, change sensors, whatever the case may be, chances are pretty good the light was on. And in the early days, everybody would panic. All you had to do was hook up the tractor, just pull it out of the shop, and you don't have to go some crazy speeds. The wheel sensors, if they detect 4 miles per hour, you watch the dash, you watch the rear light, whatever the case may be, and your light will go out. You're all done, okay? New vehicles must be capable of receiving and sending signals to turn on the malfunction light inside the towing vehicle. Trailer and dolly ABS will have the capability to send an ABS malfunction signal to the towing vehicle. Towing trailers must also be able to relay an ABS malfunction signal from the vehicle is towing to the vehicle towing it. So we're talking about a tractor hooked up to a trailer, and already mentioned about, hey, listen, I'm sitting there on the dash, you're going to have those couple icons. Okay? The way they were able to do that is this PLC, power line communications, okay? And it is a method of multiplexing, and I'm going to tell you right now, these systems were getting into that active braking, roll stability, all that stuff, stability control, wild stuff going on, guys. As each year we get the vehicles, newer vehicles, they're going to be controlled, you know, through a multiplex system, you know, can high, can low, and everything else. But everything had a kind of a start over here. So again, it's a method of multiplexing, okay? Basically, this information is converted to radio frequency signals placed on the power line, coexist same way the different radio television signals, if this is a good comparison, okay? They just have their own little frequency that they utilize. You're going to have a host and transceiver, you know, without me getting stupidly crazy in here, you know. But why do we go that direction? It provides a means to communicate trailer ABS indicator status to the tractor, basically light a light, you know. And that 7-way plug, we really didn't have no more connections, no more positions available on the standard J560 connector. Industry says, wow, this is great. We don't have to change the 7-way connectors. SAE defined it, you know, and voila. We never had to change the 7-way connectors. I went through that period in time, you know, when I first got out of the service years and years ago, and when I came back from overseas, a place I'd rather not talk about. But anyway, I remember when we had the 6-way plugs, and then slowly but surely the trailer manufacturers, and you know, they started to migrate into the 7-way plug. Then all of a sudden we had to get adapters, you know, 6 to 7-way and so on, you know, and that was never fun, you know. Only reason this slide is here is, you know, if you're talking about, you know, anything that we're getting into electronics, communication stuff, here's an example. Update to disable the PLC gateway. You know, those of you that work on cars and stuff, you know what I'm talking about, the gateway to get in there, you know, allows you to go in there. And of course you do it through a electronic tool, you know, and I'll get to that in short. But anyway, it can get complicated, you know, and this is showing you a sequence. Now, I'll be very honest with you. Merto, Webco, Bendix, they are so great. All of them are great with their troubleshooting stuff and what to do, and you get a lot of that information online. Driving mix PLC, non-PLC, don't worry about it. If a tractor is equipped with PLC, trailer is not, or vice versa, the in-cab ABS indicator lamp will not illuminate. However, ABS will continue function. See, we're back to the same thing. I got a newer tractor, I got an older trailer, vice versa, and so on. Okay, everything is compatible. Doesn't matter who the manufacturer is. Okay, they are all compatible with that PLC. You know, so that's a nice thing to have, that kind of a standard. Okay. Uh-oh, somebody's losing connection. Hopefully it's not on this end, but that's a nice, if you're losing connection, just so you know, I'm sure you're watching the chat box, you know, this is recorded, okay, and you can go back. They'll let you know anytime you want to this. So I should have mentioned at the beginning. This slide here, all I'm trying to show is components. Not that many components, guys. You got a toner ring, you got a computer, you got a sensor, modulator valve, and of course the harnesses that work in conjunction with it, you know. So it's not really that complicated of a system. And again, I spelled it out. Several key components: sensor, constantly monitor wheel speed, send wheel speed information to the computer. When wheel speed changes, indicate impending wheel lockup. It doesn't wait for the wheels to lock up. It's got the algorithm built in there. Hey, listen, you know, I'm seeing where there's a possibility of wheel being locked up. That's when the computer's going to act, okay? What's it trying to do? Via the modulator valve, reduce brake application pressure to wheel or wheels in question. And of course, the idea of the computer is, you know, I'm the brains, I'm going to adjust the pressure, seeking one which gives maximum braking without risking wheel lock. Okay? And I really don't know of any that they don't turn the retarder off. So when the ECU actually modulate brake pressure, you know, pretty near, you can take it to the bank. Anything with a retarder is going to get turned off. Okay? This continually checks itself, proper operation, detects a malfunction. Look, engine computers do it, they all do it. This is nothing new if you get into your handout and you read that portion, okay? Now, the ABS modulates brake pressure much faster, accurately than can drivers. Why? Because electronic controls are very fast, and the modulator valves are physically closer brakes than is the truck's foot brake. And it makes all the sense in the world. I like keeping things stupidly simple. Can't get any simpler than that. I compare it to a closed loop system that when you talk about emissions and the engine gets warm and all of a sudden, you know, the oxygen sensor starts working, computer takes control, adjusts the fuel and all that stuff. Well, you're basically doing the same thing over here. You got the wheel speed sensor, senses wheel slip. Remember I mentioned years ago when I got into some of the materials, I said, wheel slip, what the hell is wheel slip? Slipping across the road, you know, where I'm more comfortable with the wheels getting ready to lock up. Okay? So you have a controller that compares that information constantly. You know, the controller could be cab mounted, frame mounted, and the whole function of it is to control that wheel slip. And of course, how does it control it? If it has to, okay, it'll go into correction mode. You know, the actual physical portion of that does it are the modulator valves. They control the pressure. They could be individual valves. They could be a package, okay? And they basically reduce air pressure during wheel slip, and pressure is increased when wheel speed is stable. You can't get simpler than that. Now, there is traction control involved. That's a mirror image of ABS. Some vehicles also use a traction control system in conjunction with ABS. Traction control helps ABS improve vehicle traction by minimizing drive slip. Should a single drive wheel start to slip, traction control system automatically modulates air pressure to the wheel, transferring engine torque to the wheels with better traction. Look, just think about you're stuck in the snow someplace, your wheels are going, eh? If you had Boy Scout training, you probably took some sand or something with you. Throw the sand or, you know, whatever underneath it, and the wheel stops spinning. Okay, you're providing torque for it. Well, instead of somebody going out there, okay, you're stuck, let me put some on there, it does it automatically. Now, when this traction control came on with cars and everything, I'll be very honest with you, early days, they actually were, in my area here with the snow and ice and stuff, they kind of like, just think about it, every time you put it on, you're also wearing what? Linings and pads and stuff, you know, but they've worked through it, you know. Driving an ABS-equipped vehicle, what you might have learned about hydraulic ABS does not apply to air ABS. Important concepts, unless certain that the entire combination, I'm just reminding again, has working ABS, don't stomp on the brakes in a panic situation. One or more axles could lock. Don't expect to feel brake pulsing or hear strange sounds when the ABS activates. Unlike your hydraulic brake system where you got accumulators, you got motors and everything else, you are just, when you step on that brake pedal, okay, you have air waiting at that foot valve and you're just metering air. You're not magically giving it more air or anything else. You're actually, you can only go to as much air as you're allowed to get in that position of that pedal. Okay? Operate mixed combination vehicles. Okay, don't expect to feel brake pulsing and hear strange sounds. You're not going to have that. Operate mixed combinations with the same way one would operate totally non-ABS. Okay, this really is, you know, if you zoom in, I can't help it but try to emphasize, keep it simple. You have your base brake system in here. You got a quick release valves. All you did, you added a couple solenoids here. You're still trying to get air to the chambers, you know. So if this wasn't here, all these wires and sensors and stuff, you step on the brake, you're going to brake. And that's important because, yes, you do have here, but unless the computer says, hey, I need to do something, your wheel is starting to slip, you're just bypassing all this stuff. You're stepping on a brake and your brakes come on normally until the computer makes a decision, oh, I'm getting a reading over here, this wheel is starting to slip, you know, starting to lock up a little bit. You know what? Electrically, let's open up the valve and we'll, you know, we'll let some air out, exhaust the air and so on, you know. ECU processes all ABS information, receives, interprets wheel speed signals, okay, to determine, and again, impending wheel lockup, and when and how to activate the ABS modulator valve. Keep it simple. What's connected to this computer? Wheel speed sensors, the modulator valves, power source, ground, warning lamp, blink code, and so on, you know. And of course, the ECU also makes self-diagnostic checks during normal operation. So it's not like an engine where you have a cluster of harness of all sorts of huge plugs and everything to contend with, okay? It's kept fairly simple. Okay? During the braking, ECU uses the voltage pulses from the wheel speed sensor to determine wheel acceleration decel. So if the ECU determines that the decel rate of the sensed wheel suggests imminent lockup, it's going to command the ABS modulator valves to modify brake pressure as needed. Okay, and of course it's going to send a signal to the warning lamp or blink code lamp to communicate if there is a fault. Okay, and again, I already mentioned it's going to send a signal to retarder control in cases where use of engine brake on low friction surface might lock the wheels. Okay. In a constant power system, the ECU activates, then begins a self-diagnostic check of the system when the ignition is turned on. Okay, and you'll always hear that click, 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 click. In a stoplight powered system, the earlier systems, the ECU activates when you apply the service brake. And again, you run across trailers, if they're March 1st, 1998, they have to have constant power to it. Okay, stoplight power is used as a backup in case you lose that constant, that blue wire. Okay? And again, I even threw this in, you know, this was right picture on the trailer, okay. Trailer is equipped with anti-lock brake system, number 7, blue circuit reserved for continuous power. Just to verify everything I've been saying here, you know. Towing vehicle must supply minimum of 10 amps at 12 volts. See, I like this because right there, if I put my amp probe on there and my voltmeter on, I know exactly what I need to get out of it, if that makes sense. Yeah. All ABS, and Bendix has what they call a chuff test, okay? All ABS systems go through initial self-test when powered up. Basically, is a bulb check and test for any issues with ABS. Typically, it takes 2.5. This shelf test, just so you know, became an issue. I think a couple years ago in our state, I had one of the enforcement guys call me up, and they got caught into kind of like, you know, there's some trying to some false violations were written. It wasn't clearly cut. It was making everybody's job in enforcement when this guy came into play on how to check the ABS, some certain do's and don'ts. So he asked me if, you know, could I help him out, write a call for action with the CVSA, and then it wound up being nice because then they put a service bulletin out to address this type of an issue so everybody understands how that works, you know. Now, going beyond that, so for example, Meritor system, you will hear clicking coming from the modulator valves. With all systems, if the bulb goes out, you got no issue. Up to this point, that's as simple as it's going to get. That makes sense. Now, that back to a shelf test, okay? On constant, this is on appendix. This is a separate test check that kind of confused everybody on the roadside. On constant powered systems with ignition on, air fully charged, and service brakes applied. So if you had the guy step on the service brake, you would hear this air and puff and all this stuff, and that confused everybody. Their system energizes the modulator valves in a specific manner to allow, via the air puffs, a technician opportunity to verify they're operating properly. So if you're over there and you hear the puff, 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 it's like, hey, I think you got something wrong with the ABS. And that's what, you know, on the enforcement side had to be addressed. You know, if there are any issues from first initial tests indicated by active DTCs, the stop lamp cross-check portion of the shelf test will not be carried out until all DTCs are fully diagnosed. Tests, again, cannot be formed if wheel speed sensors, you got to be sitting there, okay? So if you're performing just an ABS check, make sure you are not applying the service brake. It could lead you to a wrong conclusion. Okay, so I just wanted to mention that, you know, that's why I said on that previous slide, everything up to that point is simple, you know. Computer-wise, I don't want to spend 2 minutes. This is a computer. It doesn't matter where it is. It's just a bank of memories over here. That's all it is. That's the inside of a computer. I'm looking at the clock. We got about 10 minutes left, and I got a lot to do here. So if you've never bothered to think about it, this is the sensor voltage pulses. Pulse generator sends out weak ACs, and then it goes to amplifier. This is inside the computer. It tries to make it a little bit stronger. Well, these digital computers, they have no clue. You know, if you're sending this out over there, it's like, I have no clue what the hell you're talking about. They live in a world, you know, of on, off, bits, bytes, binary codes and stuff. And here's your memory over here. You know, this gets converted to that. And if the computer decides, ooh, we better do something, okay, and basically it's going to turn on that solenoid. So that's your little 101 on computers, you know, just not trying to make it complicated. Now, you can go in there a lot of ways. You can get these codes. Everybody's got their own way. This is a print out from my J-Pro. This is on the truck, so you can go right into your 9-pig J1939 plug and everything else. It catches it, gives me a printout, you know, and so on. Now, keep in mind, next month is when we're really going to get into the diagnostics portion, you know. So, but they're easy, you know, the computers have that provision that you can get as much information out as you can, you know. And just a couple of slides. So next month, this is a computer, this is a board setup I use, but this would be equivalent to a in-cab computer, you know. Now here's the modulator valves. They regulate the brake application pressure to the control brakes. Again, if you're not receiving any commands from the ECU, you know, it's just going to be a pass-through. You're going to put your brakes on just like you would normally, okay? However, the ECU can typically command the modulator valve to reduce the brake application, hold existing pressure, or allow pressure increase. Again, however, it cannot increase the brake pressure above that applied by the driver, you know, your foot pedal. Modulator contains 2 solenoids. If the ABS control brake are controlled by relay valve, modulating valve may be incorporated into the relay valve, control the input to relay. Could be a separate valve. You're going to have, regardless, you get 3 ports: supply port, delivery port, and don't forget you're going to have an exhaust port, you know. You have this in your handout over there. It just walks you very briefly, you know, what happens inside there, you know, what happens with solenoids. This is what your typical steer axle and drive axles might have had that too, mounted between the relay quick release valves. Okay, they control the air pressure in the brake chamber during ABS control. Supply, hold, release, supply, hold, release. That's what you're doing with these. This is out of an external modulator valve used in conjunction with the ECU. This is a specific system, 4-sensor, 3 modulator, premium configuration, controls air pressure brake chamber during ABS mode. This valve adjusts air pressure chambers, you know. I opened this up. If you ever open up relay valves, here's your little piston that goes up and down, closes exhaust, opens up the inlet. Okay, the difference with this relay valve here, you do have that electrical solenoids in there. You know, you see them right over here. This is your typical, you know, you got a common exhaust supply, you know. I'm gonna real fast, let me turn around. I thought I had it working on a click, and maybe I can get this to come on real fast.
So where are you starting from?
We might run 5 minutes late, guys.
Whenever you...
My fingers are on it just so they don't pop out. But the bottom line is I'm using a power probe and I can make some changes. So for the sake of time, this is another one here. I'll give you a little backstory. This is a good one, okay? Let me go back and I'll do it one more time. Hopefully you can hear it, okay? And if you got to jump off, guys, you know, just so you know, I'm going to keep it going. You will have access to all this. But what this is, I got a phone call from, it was Paul out of Syracuse area. I'm looking at Bobby. He's doing my camera. He's an ex-commercial vehicle enforcement guy, you know, so he's looking at me like, you know, now he's smiling. But anyway, I got a phone call, and Paul, the one who was Syracuse, quite a ways away from me, he says, hey, it's at the end of the day. If I send you a video, can you let me know what the hell is going on here? So it was the end of the day, and basically they had 2 guys on there just to finish the day. They were in the middle of it, and they didn't expect this. You know, one of the guys is thumping the tire to look for soft tire, and all of a sudden the other guy happened to be underneath it. Otherwise they would never in a million years found this. The other guy said, whoa, every time you thump the tire, the push rod would come out, you know. So he did it a few times. So he sent me the video, and I called him back. I says, Paul, do me a favor, go up to the driver, ask him if he's got the ignition key on. And I could hear him, driver key on. I says, thump it again, you know. Yep, it's coming out. Tell the driver shut that ignition key off. He shuts it off, thump it again. Stop thumping. Did it over. Key on, key off, key on, key off, you know. So I says, Paul, I says, you know, it has to be the ABS portion of it, okay? Because you got the modulator valve, you got all that stuff involved with it, and for somehow that thumping is activating your brakes over there, you know. So, but the bottom line is now, you know, where do you write this up? You know, what do you do? So I told Paul, I says, listen, I says, I'm not quite sure if you're going to put anything under 355, but you put it under, yeah, I'm getting brain dead. 396 in the catch-all, 396.3, you know. But the reason I told him that was that, you know, you really do need to make a notation, you know, if you're not going to write it. You need to make sure somebody in that fleet knows it, because if this guy's going down the road, and this is, of course, you know, New York State, and he's hitting ice, and this guys going over rattling bumps, and this wheel starts braking by itself at the wrong time, you could set yourself up some issues. But this is a nice thing with working with enforcement guys. I get a lot of videos and stuff, and we network together really, really great, you know. So let me move on. This is a front axle valve package, quick release valve, 2 ABS, okay. Rear axle, we already held that in my hand. Of course, you notice it doesn't have the solenoid for your either the active braking or for your traction control, okay. Rather than, you know, what's inside this thing as technicians, and I will repeat some of this stuff, that we need to fix this stuff. It comes in a code, and if you look, this is a typical 12-volt solenoid. You only got 3 pins. You got a common, you got an inlet, and an exhaust, okay. And you see that, not cast in stone, but as a general rule, 4 and 8 ohms. And I'm going to tell you right now, when it comes to 4 to 8 ohms, this is your meter. Just think about it. If you were taking a reading, it came up 10 ohms, and I told you 4 to 8 ohms, that's 2 ohms more. Shame on you if you did not do this first with the leads and see what if you have so much, you know, resistance in your leads and so on, and of course you didn't account for that. Maybe you had 2 ohms in here. Now my fluke is nice because if I put them together, I hit the 0 button, and I'm kind of like, you know, I'm down to 0. Already corrected took away my resistance in the lead. So, and of course, here's your easy listening, click, 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 click. Like we're going to continue this next week, you know, next month, excuse me. Wheel speed sensor, exciter, ring, sensor pickup, commonly called the wheel speed sensor, okay. All it is a pulse generator, guys, okay. Generates pulses of electricity as the teeth exciter ring passes in front of ECU. Strength of the gap. Look, let me do this real fast. Bobby, let me zoom in on this real fast. I'm gonna put, let me know when you get a good picture in there. You got a good picture? I happen to have a sensor over here. I'm gonna hook up my leads. They're not polarity sensitive or anything. And this is your wheel speed sensor over here, okay? I'm gonna, just so you see this here. Now, yeah, that's perfect. What I wanted to do was I brought a wrench over here. So look at my meter. That's all I'm doing. That toner ring goes by there. By the way, I'm checking this, right? I'm generating AC voltage, okay? It's that simple. Keep it simple, okay? And like I said, next week we're gonna keep on, you know, we'll do, next month, excuse me, okay? Pulse generator, the nice thing about this is, guys, you change a sensor, just push it in. You're done. It will find its automatic gap, okay? Till you make contact, wheel end play will find a sweet spot, okay? Required gap, 40 thousandths or less, okay? However, they are sensitive, so you want to make sure your wheel bearing adjustment. I've had vehicles where it could go for this, and I've pulled, like for example, it's a pain in the ass to pull rear dual wheels when I want to check the bearing adjustment and everything else, you know, to get at it, you know, pop the axle out, and I could just barely turn my axle nut to do just a little minor adjustment, and guess what? Light goes out, you know. Sensor arrangement, it could be either mounted or integrated with the hub wheel. Again, the gap is so important on these things, okay? Real world. Unfortunately, this is what we wind up with, and then you go to change that sensor, it does not want to come out. Everything is corroded in there, and in my shop, you can stay there, Bobby. In my shop, just to save time, I don't even mess around. I keep a whole box full of these, all sorts of different, you know, sensor brackets to make my life easier, because you can spend a lot of time with these things, you know, again, real world. When the wheels are one tandem axle as wheel speed sensors, sensors are usually placed on the axle whose wheels are most likely locked up. A lot of guys don't realize this. On a tandem axle with spring suspension, sensors are generally on the lead axle. Tandem axle with air suspension, sensors are generally located on the trailing axle. And I have gotten it wrong, seen it wrong from the factory. Guys come in, complain, gee, my wheels tend to lock up and everything else. So keep that in mind. Most common sensor resistance is 7, and this is not cast in stone. You get in some of these systems, they'll tell you 900 to 2000, but I'm just using a general number here, okay? And we'll do that next month. We'll actually start measuring the sensors and look at what kind of, we're actually going to turn the sensors, see what, if we get the right voltage and stuff, you know? So, diagnostics. Look, guys, you can do flash codes, you can go into a computer. I mean, they really did make it nice to do that, you know. So, for example, you have a toolbox. Toolbox is nice, and basically what I have is, I have a J-Pro, you know, and I have for trailers. It is so nice. I'm going to make a mess over here, but if you can scoot back, this is nice. You know, I put my 7-way plug in here. I can power it up a couple of different ways, and then I can get into my toolbox. You know, that's the Meritor software. Right? And on the J-Pro actually in their system, the Bendix is an ACOM, and that actually they made a deal where the ACOM is part of their software. So, again, you know, we'll get into all that next month. ABS, might use an ABS malfunction lamp, signal stored fault through a blink code. You run across vehicles that actually have a blink code switch. You might have to look for it, you know, be someplace, you know. Bendix used LEDs for a long time, okay. I'm not going to get into that, get into next month, but this is a, oh no, real fast. Like I said, if you got to jump off, okay? If you got to jump off, go for it, because it will be re-recorded. In my shop, I got all the fanciest software. I told you it's J-Pro, I got a Can-Do, and you know, all the stuff. But sometimes I pull a trailer in, it's just as easy. I got a little battery down here, got my 7-way plug, hook my power to the blue wire, there it go, ground, and I can just go like this. First thing I do is, without hooking up the laptop or anything else, I just look over at the side of the light. It came on. Click, 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 it went off, move on, okay? Pull the plug out. By the way, I can check my lights and everything with there. If the light did stay on, however, and I do have all the information, I can go off, on, count the blink codes. I go in my little book, and it'll tell me what I got. So everybody's got their favorite method of doing stuff, okay? Traction control, again, we talked a little about this. You're basically braking the spinning wheels and sometimes throttling back the engine power, okay? They're integrated into ABS ECU. And basically, air pressure applied to brakes is supplied by a solenoid valve inserted into the brake control line going to the relay valve. I showed you that little solenoid. And again, it applies brakes on the spinning wheels when a wheel speed sensor tells the ECU. So you got the existing stuff in there anyway. You got the wheel speed sensors, you got an ECU in there, you got the solenoid valves. That's why I said it's a mirror image of ABS. ABS takes pressure away, keeping it stupidly simple. Traction control puts pressure to the wheels, okay? One benefit monitoring wheel speed with a tooth wheel, and this thing over here basically says, you know, a lot of guys, if they have an issue, they'll take a blowgun and they'll start blowing away the dirt. You're not really doing anything, you know, because dirt has the same magnetic properties, you know, as air and all that stuff. Now, I grant you, if you have rust pieces in there and stuff, yeah, it will affect your ABS, you know. Keeping it simple, guys, if you work on this stuff, if you work on the engines and stuff, I have a broken wire over here. I use my little tool, extract the end out of it, There it is, okay. I put a new wire through there, put a new end on, crimp it, and in my area, everything gets shrink connected. You know, you heat, make sure nothing gets in there, tie it up, secure it, and I'm on my way, okay. This came from the CVSA thing, you know, must yellow light up, has a malfunction, okay, required, we're repeating ourselves here, you know, all trailer dollies built after, you know. Location, however, when these things came out early, man, I used to see the ABS, I'd have to look for the lights, but it was still a requirement, had to be someplace, you know, there was no standard, just like with the OBD DLCs, you know. Now, this is huge. Back in 2016, Appendix A, just so you know, is those of you that do federal annual inspections, you have to follow this. So basically what happens is they put it as part of the annual inspection that if, for example, the ABS isn't working, the light is on, you rechecked it. Okay. Years ago, prior to 2016, it wasn't an annual inspection requirement. You still get violations on the roadside because it was in the federal regulations. In your handout, so I don't go through the whole thing, make sure you go in your handout and you look at for these exemptions, because you might run into a heavy trailer and say, oh my gosh, it doesn't have ABS. It's exempted. So keep that kind of stuff in your mind. Now, I'm almost done with this. I mentioned that you don't really need a computer to work on these, and I'll bring that up again next month. This is one system you need to have a computer, okay? This has a roll support system, roll stability support, RSS. This provides additional assistance to maintain trailer directional stability with stability support. So it's quite a little bit more complicated internal. It's got a lateral accelerometer in there, you know, and all sorts of stuff, you know. And basically, let me go in there. This is a pricey computer. And when we first started getting this thing, it's like the complaint with the driver was, I stepped on the brake, I actually had no brakes. And that's counter to what I've been taught, that, you know, you will always have brakes even if ABS fails. But I'm not going to spend much time on it. But anyway, when this fails, okay, and by the way, these are mufflers. There's an exhaust coming out of there, and that can be an issue too sometimes. See these little mufflers here? They, in our climate here, between the road salt and everything else, you can take those out, just so you know. Sometimes you might even fix that problem. And if you look over here, look at all the crap in here. It's like a filter, a muffler. You can unroll it. I've unrolled it, I've cleaned it, and re-rolled them back up clean, dried them off and everything, you know. But this is what I'm talking about. If you don't have a computer, don't take that job on, because once you change your computer, you're going to have to do some end-of-the-line testing with this thing. So basically, you need to go into your toolbox, and you see WAPCO Trailer RSS Diagnostics, and what it does basically is it goes through a bunch of checks. It checks, of course, naturally wheel speed sensors and so on and so on. So what happens is, in this particular case, and I'm just going to keep it very brief, let me see what I had. You need to check up the trailer, because it does got lateral accelerometers in there, so it needs to know how my suspension is. You let it down, okay, and if you follow the prompts, believe it or not, you have your lines hooked up over there, and it'll tell you spin this wheel, you spin it, and all of a sudden automatically go pop, locks it up, tells you to go to the next wheel, pop, pop, locks it up, and you walk all the way around the trailer like this. Well, I used to get phone calls, you know, a lot of the guys didn't have the software, so yeah, I'll come over, we'll do it and stuff. Sometimes the guys would have the software, they would do it, and they go through the whole check, and it's like, the light still stays on. And I'd have to tell them, look, the final check, to be honest with you, you know, is they want to see all four wheels spinning, all the sensors saying the same thing. So you got a choice. See, if you get four sensors, four wheels, you get four guys, and if you spin the wheels at the same time, I've been very lucky, right in the shop it goes out, or let it down, take it out, you know, you're pulling out of the shop, the light is on, just within a very short distance, computer is happy, it sees it, and your light goes out. So, my final thoughts. Many manufacturers use the ABS platform, provide various other safety systems. You needed that ABS first. We talked about traction control, okay? Improves traction in various road conditions such as snow and ice. Simple terms, I already used it. ABS reduces brake pressure, ATC applies it. Then we went into electronic stability control. It's utilized to prevent rollover, maintain directional stability, keep the vehicle traveling on its intended path, spin out, and so on. Okay, and now we do get into a little bit more complications. As you see, you have more valves. Okay, tractor protection, active brake valve. We discussed that. You know, braking valving in the front, and of course, much more. You know. Active braking systems, they utilize valve solenoids, provide braking during ATC or ESC events. All the aforementioned, coupled with various sensors, cameras, radar, allow manufacturers to ease into collision mitigation. For example, WAPCO's got their On Guard, Bendix has their Wingman, the Fusion, they've had it for years. Okay, and they are driver assistance systems. Just like cars, these systems have become very sophisticated. One commonality with all these systems is electronics, sensors, radar, modules, and so on. My question, and I'll leave it off, is are you informed enough to diagnose and repair these systems? And this possibly could be a future lunch and learn, because it's just like you guys that work on cars with the ADAS systems. I'm foreseeing some possible issues, and they are looking to mandate these on these vehicles, which is another story. So listen, I just put the slide in, okay? This is from Dorman, okay? Now, on September, I forgot the date, 23rd, okay, because I got a lot on my mind, 8 a.m. to 6 p.m., they are going to have a all-day training event, and this will be on cars. It's not going to be on trucks. Last couple years, I did some stuff over at Dorman, and we did it on a Sunday. I did the heavy-duty stuff. But these guys right here, okay, G. Trugley, of course, runs this whole Dorman training stuff here, okay? Kenny Sanders, okay? Pete Meyer, I mean, they're friends of mine. They are great. They're about the best trainers you're gonna see in the whole country. So if you are interested, or you have anybody that's in the automotive and they're interested, boy, you should really consider going there and doing this. Like I said, not only are they personal friends, but they are the top instructors that you're ever gonna run across. So keep that in mind, okay? If there's any questions, I know I kept this going, okay? A little longer than I should. I mean, I'm one of those 10 pounds in a 5-pound pail. But if there's not any questions, okay, again, I gotta remind you, part 2 will be coming up next month. I will do more live stuff, because we don't have to do any more of this. This is how ABS works. So I enjoy doing some live stuff. We'll slow it down a little bit, and I said I got a board. We'll use meters. We'll actually use a lap scope, PowerPoint, and whatever it takes, maybe amp probe, we'll have some fun in it. So I will let you guys go, because I am in the same boat as you guys. As soon as I'm done, this shirt comes off, my shop shirt goes on, and I'm out in the shop, getting my hands dirty and busted up just like you guys. Everybody, keep the faith, and thank you for showing up over here.